Dr. Indrajeet Jain, sir, an assistant professor with 27 years of teaching experience and specialization in structural engineering. He has, good evening, sir. I hope you are there. You are listening to me. And,
Yes,
sir,
ma'am.
yes, sir.
You?
Good evening, sir, and
Good.
welcome to the session. Basically, Indrajit Jain sir has written a lot of publications, a lot of books. You can also buy the books written by him from Amazon as well. Even we have also, checked a lot of his publications. It was really very nice and knowledge-oriented books. We prefer everyone has to buy and everyone has to prefer such books. We also have,
I'm just sharing my PPTs.
sure, sir.
I hope that my PPT is visible.
Yes, sir, it's visible.
So, yeah, good evening to one and all. So, welcome to all the aspirant who is desire their dream in this GATE Academy. So, GATE, as you know, that it is uh, a entrance to for higher educations or some government sectors. So, here I'm just delivering you for the subject uh, engineering mechanics, the part of structures. So in this particular syllabus, system of forces, free body diagram, equilibrium equation, internal forces in structures, friction and its application, center of masses, free vibration of undamped single degree of freedom system. The syllabus which is designed by the GATE, and to achieve this syllabus, some questions, the engineering mechanics part is very less, hardly 2 or 4 marks question is there. But engineering mechanics is the base to all the subject which is comes under the head of structures. So system of forces, as we learned in our engineering mechanics first year, that force is a uh, force is an agent which changes the state of the body from rest to motion. So in civil engineering, all the forces which we consider are in acting on a rest body. And when forces acting on the body, single force, we call it as a force. When the forces are one, more than one, then it is system. And there are different types of the systems. So here on screen, you can see that there is a force system, and that's our coplanar force system, concurrent force system, collinear force system, parallel force system. And name itself indicate that when the forces are lies in the same plane, it's a coplanar. Forces acting on the same point, then is a collinear, and forces when are acting in the same line of action, then is a concurrent force system, sorry, collinear force system. So these are the various force system, and this effect of the force system on the structures are differ, and based on that we have to apply the different formulas. Now, while learning the force system, we have to also focus on the resultant of the forces. And resultant is nothing but a single force which having same effect as that the forces together. In the above figure, you can see that the truck is driven by or pulled by 3 people. And these 3 people are replaced by the single person. And the force applied by single person will be equal to the number of forces applied by the 3 person. So this is replacement of number of forces to a single force is nothing but resultant. Now, after that, we will learn the equilibrium. Equilibrium is nothing but a set of forces which keeps the body in rest. And we will, as we have a very limited time, so I'm not going to be explain much more theory, as you already completed your graduate or you're in the third year or final year of your engineering. So this is a sample numerical which is based on your equilibrium. And this is a question which was asked in one of the university for GATE examination. So you can see that this is a cylinder of radius 250 is given. Just a minute. So here Just a moment. Yeah. So in this particular figure, you can see that there is a weight, or just look out this particular figure. There is a cylinder which having the weight W, and this cylinder we have to raise over this step whose height is 150 mm. Now the cylinder radius is given 250 mm. So radius of the cylinder is given 250 mm. The weight of the block is given 10 kilonewton, and the height of this step which is given 50 mm. The force is given which is horizontal force. Force is a horizontal force P. So like this, everything is given over here, and this cylinder will be move on this particular corner of this step. They're like this. The contact between this floor and the cylinder will be reduced. Yeah. So now here you can see that here this is a radius, that is 250 mm, and here also there is a radius which is 250 mm. Are you able to hear this? Are you able to see this particular? Now this size is 50 mm. So I just help you how to solve the numerical which you are asking in your gate examination. So here this is 250, and the block height which is this one is 50. So this height will become 200 mm. Clear? And this radius is here again 250. So by solving the Pythagoras theorem, you will get this horizontal distance 150 mm. By Pythagoras theorem, this horizontal distance will get 150 mm. Now we can solve this method, this numerical, by Lami's theorem or a different method. But a simple way to solve this numerical is, we have this horizontal force P, and we have this vertical force weight, and the reaction which is passing through this corner from here. If you take the moment of all these forces from this point of rotation, so only two forces will be there: horizontal force P and vertical force W. And if you take the moment of these two forces about that corner is equal to 0, so P into the vertical distance Y and is equal to, which will be clockwise, and this force will be anti-clockwise, W into horizontal distance X. Now see here, P you have to calculate. Y value is known to us, that is P into Y. So P is the horizontal force and vertical distance is now 200 mm. This distance is vertical. This is 200 mm, and weight is given in your numerical, that is 10, and the value of X by Pythagoras theorem will get 150. I'm not going to be solve Pythagoras theorem here because it's just an introductory lecture, but by Pythagoras theorem will get that, and from this you will get the value of P. It's very simple to solve such a numeric. Clear? Like this, it's a 3 by 4, that is 10 into 150 upon 200, you will get the answer. Clear? Like this, we have to solve the numeric. So in a very simple way, shortly and conceptual way to solve the numerical, there is no need to go for the rigorous method. Then next, after this, there are the numerical on the beam. So this is a numerical from 2023. So when solving such a numerical on the beam, we must know the basic concept, that is this supports. So you can see that the support P is a hinge support and support Q is a roller support, and hinge support has two reaction and roller support has one reaction. So this basic concept must be known to us, that is hinge support has two reaction, that is horizontal and vertical. Clear? And roller has one reaction, that is always perpendicular to the uh, support, one reaction. Okay, so here it's a hinge support. Hinge support has two reaction. We can apply horizontal and vertical. Roller support has one reaction. We can apply vertical reaction. What is the requirement of the numerical weight? We have to see properly in this examination, because we don't have time to solve by a regular method. We have to solve numerical in a single step. Being subject to the system of coplanar forces, as shown in figure, the magnitude of vertical reaction at a support P. So this is support P, and support P, we need only vertical reaction, that is with is VQ. Clear? Now in this numerical, you can see that there is an inclined force. Now we have to resolve these forces depending upon, to observe their head and tail. Here there is a head and this one is tail. So we will keep our origin on the tail, the force of fourth quadrant. So your x component will be rightward and y component will be downward. This is 500 cos of 60 and this is 500 sine of 60. Clear? So the concept of resolution which we learn in the unit 1 or first basic, that is very important to solve the further numerical of mechanics. Then after this, see here there is a force on a bracket. This is a bracket, and on which there is a horizontal force. So the equivalent of this horizontal force will be, we have to apply the same force here, that is 100 Newton, and also produce a couple. So here this forces is converted. Means if I draw here bracket with horizontal force, so this will be equivalent to this, the horizontal force, and a couple will be act at that point, and the couple will be depending on the horizontal force and its perpendicular distance. So in next figure, I had drawn the FBD. You can see the FBD. Here there is a horizontal force, that is 500 cos 60. Then the couple is converted, that bracket force is converted into horizontal force, and a moment is 100 into 50. And that's it. This much only the conversion in this particular numerical. And then we apply the condition of equilibrium. There are three conditions of equilibrium. Summation of fx is equal to 0, summation of fy is equal to 0, and summation of moment is equal to 0. So in being, as we want to find out this particular reaction in our gate examination numerical. So what we will do, we will take moment on this support. So in a single step, we'll get answer. We are taking the summation of moment. So moment, this is moment 50 kilonewton. This moment is 50 Newton meter, that we have taken directly without multiplying a distance. This is summation of moment. So clockwise is positive, so I have taken positive. Then after that, this is the 200 Newton force with respect to point Q. It produce a moment with respect to It was some sensor issue. Yeah. So this will produce and again a clockwise movement. So here you can see that this value 200 into 2.5. Why it is 2.5? So with respect to Q, the distance is 1 plus 1.5. So 1 plus 1.5, it is a 2.5 counterclockwise. After that, the next force which is come, this is which is 50 sine. This one, 50 sine of 60. This force is, and that moment of that force with respect to Q, we have to consider moment is nothing but force into perpendicular distance with respect to reference point. And our reference point is Q. So force is downward, but the moment due to that force will be anti-clockwise here. Here we are not clockwise or anti-clockwise, sorry, whether it is downward or upward. We are only observed by movement, whether it is clockwise or anti-clockwise. So this 500 sine 60 would you say anti-clockwise movement. So the moment at this point, the sign of that moment is negative. Right? Because we say anti-clockwise movement around the Q. And the distance with respect to Q is 4. Then after that, this next and last force Vp, which produces a clockwise movement with respect to Q. So Vp into 6. Solving this, we'll get the answer that is 197. And if you go through the numerical, you can see that it's a numerical answer type question, no negative mark for such a question. And your answer is round up to 1 decimal place. This is a numerical from GATE 2023. So here we will not get any options. We have to solve this numerical and directly place the value. So here there is no option over there. There just you have to enter this value 197.0. Clear? So this is the another type of the numerical. Now again in equilibrium, this question was asked in one of the university GATE examination, which is based on the probe cantilever and having the internal hinge. Whenever there is an internal hinge, the numerical can be solved by the simple way of statics. So here we know that internal hinge, the moment is always 0. So here the moment at the hinge is 0. So here there is a hinge and we'll break our beam into 2 parts and we take the moment about this one. So taking moment about hinge and we consider the left part, sorry, the right part of this one where the V reaction RY is the vertical reaction. Here is the fixed support having 3 reaction, horizontal reaction, vertical reaction and a moment. But since there is no inclined forces or inclined support over there, the horizontal forces will be 0. So only vertical reaction and a moment at the cantilever, that is fixed support. And at roller support, there is only one reaction. So when we take the moment of these forces, so RA into its perpendicular distance, this is your RA. RA into its perpendicular distance from hinge is 2 meters. So sorry. So this is your RY into 2. And then the equivalent point load of this UDL is 10 into 2 meter, and that acts at the sorry, oh, it acts at the half of this one. So here we have taken the moment that is the sign will be opposite. One is clockwise, other is anti-clockwise. So 10 into 2 is the current force and will be act at a distance 1 meter, and Ry, that is the moment of reaction. By this, you will get a reaction 10 kilo. Once you get a reaction of Ry in this numerical, if you see this, what we have to calculate? We have to calculate the vertical reaction at support A, support X, and support X is the fixed support. And why we have not calculated directly on the right side, sorry, left side of the portion reaction Rx, because Rx having the two reaction, that is moment as well as Rx. So if you take the moment on hinge on the right side, so you'll get the Ry, and second step when we apply the summation of Fy forces for the whole system, for this whole beam. So Rx upward reaction, this one, and Ry, this upward reaction, upward is equal to downward, and this total UDL of 10 into 4. Clear? So that 10 into 4 will get equivalent UDL, point load of the UDL, and Ry value is known to us, that we substitute over here, we'll get the value of Rx is 30 kilonewton. So like this, we can find out the unknown forces or reactions in a very short time. Okay. So concept must be clear. You must know that internal hinge there at that time, the moment of the hinge will be here, 0. Then fixed support has 3 reaction, roller support has 1 reaction, hinge support has 2 reaction. UDL equivalent point load will be W into L and will be act at its mid, that is L by 2. So if basic concept is clear, then you can easily solve. Then after this, we will focus on the friction. We know that when two forces acting on the body, one force opposes the motion of the other body. So this force is called as a frictional force. So the forces, this figure, clear your idea that what is friction. And frictional force is always opposite to the motion of the body. Frictional force, the concept of frictional force, you must keep, it is always opposite to the motion of the body. Now, some law of friction. The first I already explained, the frictional force is always opposite to motion of the body. Frictional force is always tangential to the contact surface. Then limiting friction force is directly proportional to normal reaction. And this is very useful for solving all the numerical of friction. Frictional force is equal to mu into S. That is coefficient of friction. And this coefficient of friction in static is always greater than the dynamic. So this is one numerical which was asked in GATE examination, which is based on friction concept. A horizontal force of P kilonewton is applied to the homogeneous body of weight 25 kilonewton. As shown in the figure, the coefficient of friction between the body and the floor is 0.3. Which of the following statement is correct? Now see here, in examination, there is not necessarily always a single answer will be a correct. Now, MSQ will be there, so multiple questions will be correct. So let's select the multiple answers here. So let us see that in this particular statement, there is a single answer is correct, double answer, 3 answer, or all 4 are correct by solving this particular numeric. So here, the horizontal force is applied at the top corner of this rectangular object, whose width is 1 meter and height is 2 meter. Answers options are given. The motion of the body will be occur by overturning. Second option is sliding of the body never occur. Sliding कभी occur नहीं होगी. Third, no motion occur for P less than 6 kilonewton. And the third, the motion of the body will be occur by sliding only. So these are the 4 options. Let me check. Overturning will be there. So we have to apply the overturning condition. For overturning condition, what will be there? See here. Overturning में क्या होगा? This is the corner, that horizontal force. Yeah, this is the corner. Here somewhere will be the weight of the object W. This horizontal force will tends to overturn this body. Clear? Like this one, from the tip of this corner. So horizontal force tends to overturn, whereas this weight is the restoring this body. So we have to balance this horizontal force, that is overturning moment must be equal to restoring moment due to this weight, and weight will be occur at the CG of the rectangle, that is 0.5 meter. Clear? So in my next PPT, it is shown. That is, yeah, okay. See, this overturning moment. Overturning begin when the moment P equal to moment by P equal to the resisting moment by the weight. So horizontal force you have the force which is applied at top corners, that force into its perpendicular distance 2 meter. Here, that horizontal force P into its perpendicular distance 2 meter, that is the overturning moment. So P into 2 is the overturning moment, and which will be balanced by this weight. You can see there this weight, and whose distance is 0.5, and this is a restoring moment. So that is 25 into 0.5. By solving this, we will get overturning will be occur. That force when which is applied 6.25 kilonewton, overturning will be occur. So here when the overturning will occur if the value of P is greater than 6.5, the overturning will be occur. Up to that, the body up to 6.25, the body will be in the state of rest. If the value of the P is greater than 6.25 kilonewton, overturning will be occur. Clear? So this is a condition for overturning. Now the sliding. Now this horizontal force which is acting at the top P, that will try to slide the body. So here at the bottom of this body, here there is a, sorry, I will just, this is the bottom, let's consider the bottom of the body, and here there is a frictional force will be occur. Clear? At the bottom of this surface. There is a sensor issue in my notepad. So let us see later. So here this frictional force, which is the maximum frictional force occur at the bottom, that is mu into W. Frictional force is equal to, is directly from normal reaction, and normal reaction which is occur here, when you take the summation of Fy is equal to 0. So normal reaction which is acting at the bottom of the body will be equal to the weight of the body is equal to 0, and N is equal to W. The normal reaction is equal to weight of the object. So here that frictional force is equal to mu into N, and N is equal to W. From this we'll get the sliding force. The sliding will be occur only when here P is greater than 7.5 kilonewton. So which one is occur earlier, sliding or overturning? Sliding will occur at the force which is greater than 6.7, and whereas overturning will occur when the force value is greater than 6.25. So first is occur overturning, clear, and then sliding, clear. So the options which are given in our this one, see, the A option is the motion of the body will occur by overturning. So definitely the motion of the body will be occur by the overturning, because overturning will be occur first. Sliding of the body will be never occur. स्लाइडिंग कभी ऑकर नहीं होगा, क्योंकि न्यूमेरिकल में क्या दिया है आपको, द वैल्यू ऑफ द, सॉरी, या सो यहाँ पे जो आपको पहली कंडीशन है इसमें, in the first condition you can see that when we compare the sliding and overturning, so first your value of the overturning is less and your object will be uh, fell into the or turn due to the overturning. So overturning will be occur, the motion of the body will be occur due to overturning is correct. Sliding will never occur. क्योंकि overturning पहले आएगा तो sliding आएगा ही नहीं. No motion occur if the value of P is less than 6.6 kilonewton. Why? Because our values are 6.25 for overturning and for sliding 7.5. If P is less than 6 kilonewton, so no motion will be occur, your system will be in equilibrium. And the last option is the motion of the body will be occur by sliding only. So here the motion of the body will not occur by the sliding because sliding will occur at the end. पहले overturning आएगा, then will be sliding. So in this particular numerical, sliding will not occur. The correct options are A, B, C. So we have seen the NAT numerical, we have seen the simple numerical, and we can see a multiple choice question numerical. And we have seen this particular numerical where are three answers are correct. So we have to deal with properly, conceptually while attempting the numerical in your GATE examination. Never try to solve all the question. Solve only those questions on which you have a confidence. And that's why you require the perfectness in your subject. So there are some more, but I think so. The other are also waiting for the further presentation. I think we'll wait, we'll stop here and the further topic will be continued by the other faculties. Is it okay, sir? Or shall I go with the moment of inertia? I think so it is okay. Hello.
Hello.
Yeah, shall I continue or let the other faculty will get the chance to explain this one other topic?
Yes, Tapkir sir, Pradeep Tapkir sir, would you like to
Yeah, yes, ma'am.
take it ahead, or sir has to stop the session?
No, let me go with my briefing.
Okay, okay, sir.
Okay.
Okay,
So I will just
okay, sir. Thank you so much, sir.
yeah. Thank you so
Thank you
much.
so much for the insight, sir.
Yeah.
We wanted participants to ask the questions to sir. If you have any queries in the mind, time will be allocated to you accordingly. And if you have any questions, you can ask.